Welcome to the video presentation on the working of tube light. In this video, we will explore the science behind this common lighting device and learn how it produces light. In this video, we will learn about first components and its functions, and second, working of tube light. So first, we are talking about some necessary components of tube light. The first one is the fluorescent tube. Fluorescent tubes produce light using a process called fluorescence. When an electric current is passed through the gas inside the tube, it excites mercury atoms, which emit ultraviolet UV light. The UV light then strikes the phosphor coating on the inside of the tube, causing it to fluoresce, or emit visible light. The second one is starter. A starter is a small device used in fluorescent lights to help them start up. It is usually a small glass container filled with argon gas and a bimetallic strip. When the light is turned on, the starter uses a high-voltage spark to ionize the gas in the fluorescent tube. This creates plasma that allows the light to start glowing. Once the light is started, the starter is no longer needed, and the ballast takes over to regulate the current flowing through the tube. This slide focuses on the components of a tube light and their function in maintaining voltage. The third one is bimetallic contacts. This component is used for two reasons. The first reason is to start the tube light. When the tube light is first turned on, the bimetallic contacts are open. This creates a high voltage across the starter, which is a small neon bulb located inside the tube light fixture. The high voltage ionizes the gas in the starter, creating a current flow. This current heats the bimetallic contacts, causing them to bend and close. This completes the circuit and allows the current to flow through the tube light filaments. The second reason is to regulate the current flow through the tube light. Once the tube light is started, the bimetallic contacts act to regulate the current flow. If the current flow is too high, the bimetallic contacts will heat up and open, which will reduce the current flow. If the current flow is too low, the bimetallic contacts will cool down and close, which will increase the current flow. This helps to keep the tube light operating at a constant brightness. The fourth one is bipins. Bipins are the two electrical pins that are located at the end of a tube light bulb. They are responsible for making electrical contact with the ballast, which is the device that provides the power and voltage needed to start and operate the tube light. The bipins are also responsible for holding the tube light bulb in place in the fixture. When the tube light bulb is screwed into the fixture, the bipins make contact with the electrical terminals in the fixture, completing the electrical circuit. The fifth one is switch. A switch in a tube light circuit is used to control the flow of electricity through the tube light, turning it on or off. The switch is connected in series with the tube light so that the electricity must flow through the switch before it can reach the tube light. When the switch is turned on, the circuit is complete and electricity can flow to the tube light, causing it to light up. When the switch is turned off, the circuit is broken and electricity cannot flow to the tube light, causing it to turn off. The last one is ballast. A choke, also known as a ballast, is a coil of wire that is used in tube lights to limit the current flowing through the tube. Provide a high voltage pulse to start the tube. Maintain a constant voltage across the tube while it is operating. Without a choke, the current flowing through the tube would be too high, which would cause the tube to overheat and fail quickly. The choke also provides the high voltage pulse that is needed to start the tube. Once the tube is started, the choke maintains a constant voltage across the tube, which is necessary for the tube to operate properly. In summary, the function of a choke in a tube light is to protect the tube from overheating and failing quickly. Start the tube. Maintain a constant voltage across the tube while it is operating. Now we will learn about the working of tube light with the electrical circuit of tube light. A tube light is a low-pressure mercury vapor gas discharge lamp. It works by passing an electric current through a tube containing mercury vapor. The current ionizes the mercury atoms, which then emit ultraviolet light. The ultraviolet light then excites the phosphor coating on the inside of the tube, which emits visible light. How does a tube light work? Here we will understand. When the AC power supply is turned on, the current flows through the starter. The starter is a sealed glass tube containing a bimetallic strip and a neon lamp. The bimetallic strip is heated by the current and bends, closing the contacts of the neon lamp. This creates a path for the current to flow to the filaments of the tube light. The filaments are heated by the current and begin to emit electrons. The electrons collide with mercury atoms in the tube, ionizing them. The ionized mercury atoms then emit ultraviolet light. The ultraviolet light then excites the phosphor coating on the inside of the tube, which emits visible light. Once the tube light is lit, the starter is no longer needed. The bimetallic strip cools and opens the contacts of the neon lamp, breaking the path for the current to flow to the filaments. The filaments continue to emit electrons due to the current flowing through the tube light. The ballast is used to limit the current flowing through the tube light. The ballast also acts as a voltage transformer, increasing the voltage applied to the tube light. This high voltage is necessary to start the tube light. I hope this video has provided you with a comprehensive understanding of the working of tube lights and its components. Thank you for your attention. This video was created by Parthiv Patel, Rushabh Solanki, Yash Thummer, and Jaydev Prajapati.